quiz in the end?
You can choose. So you can have a one consolidated quiz.
So I can have one consolidated then.
Okay, so that you can have on the second day. And can you confirm which day it will be on Monday or Tuesday?
It will be on Monday.
Or it will be Monday. Okay, I'll update the.
Mhm.
And so before we start, I'll. Amit, can you stop sharing for a moment?
Yeah, sure. Okay. Okay. Sure.
I'll just have to share some information. Um, So, as all of you know, this is the website for the school, and in this website, I'm updating. Uh,
Oh, nothing is shared yet.
yes, uh, no, I have given in the chat box the website,
Oh, okay, okay, okay.
yeah, and I'm opening the website here again. So this is some changes are made where I have given here. I can see is the link to the YouTube channel where all the um, lectures are being uploaded. So currently we are in the process of uploading and we'll link it like here. First video is linked here, second is yet to be linked. So slowly as and when this gets uploaded, I'll keep on linking the videos here, and this is the link to the playlist. Okay, here. And I will get all these things properly organized and have uh, it like lectures and materials, not necessarily code. So it will have your codes or any other document as a zip file. It will be linked here, video will be linked here, and the lecture PDF will be linked here for each one. And as and when our plan changes, this is the place where we will have change in the schedule. So right now, we are here on 16th Friday afternoon. Amir Subba will be doing Matplotlib and Pandas. Tomorrow, Tausik will be doing uh, root and uproot, part 1, and part 2 will happen on Monday. Okay. And there will be some changes here and there, so I will keep on updating. So with that notification, I request, I just stop sharing and ask Amir to make the presentation
Yeah,
and
sure.
start it.
Let me share again. Okay. Let it come. The screen is visible, right?
Yeah, it's
On
visible.
the screen. Okay, perfect. Yeah. So yeah, okay. So as Ritesh just mentioned that I'll be discussing about this Matplotlib. That's quite famous for data visualization and introduce the pandas. Okay. So subsequently there would be introduction to root data frames and pyroot and uproot by Tausik and myself in the uproot. Let's hope that. I hope Matplotlib, I guess from the responses that most of you, at least I think 80% of you must have been introduced to Matplotlib once in your life. So I won't bore you much getting into the details. Okay. So let's start with that. So if you haven't installed Matplotlib, it's very easy to install. If you are in the pip environment, you just do pip install Matplotlib. Or if you are in a conda, then you just do conda install Matplotlib. So, okay, so basically this is what I'm planning to cover today. So let's see, okay? So these are some very basic stuff that is available everywhere. I'm just trying to recap your what you already know. Okay. So, okay, let's begin. So first, let me import, let's say numpy for some data thing, and I'll import matplotlib a pyplot class as plt. Okay. So now matplotlib has been imported. I imported numpy. Okay. Let's generate some number. Okay. Well, let's say I'll use numpy and I'll say, okay, in space and see. I think this will do the job. Okay, okay, okay. A number has been generated. I'm using a simple numpy has been already introduced to you. So let's create more a function, a very simple function. Let's say numpy sine function of x. Okay, and what you can do is you can use the plot function of matplotlib to, let's see. Okay, so this is a very easy way. Like you have, let's say you have x data and you have corresponding y data made up from the x data values. Then you can simply visualize the uh, how your y values is behaving with respect to the x in this way. Okay, so couple of things you can play around with these plot functions. Okay, first thing you can do is you can change the let's say like the figure size. Okay, let's say you want to increase, you want to decrease the size of your canvas, and let's say 6.5. Okay, so this is fine. Okay, and so some more customization that you can play around within the plot functions is like, let's say you want to add a label to it. Okay, let's say, and I see this is sine of, let's say, theta, sine theta. Okay, so this is your label. And if I do this, the label doesn't come. What you have to do is, let's say you have to call a function called as legend. Okay, I'll just do plot.so. Now, this, you see, you have a label over here. Okay, and other thing that you can try, like a different thing that you can try is, let's say, you want to change the, let's say, the line style of your curve. Okay, you can have different, now it's a solid line, you can have a dash line, something like this. You can change the line width also. Let's say currently by default it's 1, you can change it to line width. You can even change the color of your curve. Let's say currently by default it's blue, let's say it's red. Okay, you want to do this. So now, so this way you can play around. Okay, other thing you can do, you can even customize your legend. Okay, so let's say you don't want a frame. Okay, you don't want a frame. Then if you do this, it's just the frame goes away. Okay, you can change the size of your, even the font size of your label. Let's say 50. Okay, now it gets bigger. So this is even you can change the color of your color of the text of your label. Let's say you want to make it red. Okay, so see, so this way you can these are nice functionality within the legend function, plot functions that you can always play around, and it's good to know that. Okay, and some other thing that you can try is, let's say you want to have you want to put the label, the X label or the Y label, that you can of course try with the command is X label. It will take let's say you want to do let's say this is theta in radian. So, and one thing, what you have to know is that if you want any text in the LaTeX format, then you have to give that text in this dollar dollar, between this dollar dollar sign. Okay, and let's say you want to change, you want to put the even the Y label, then you can do a very simple thing like this, and sorry. Then you get what you're supposed to do. Okay, so
Amir, yeah,
yeah, yeah,
can
yeah.
you increase the overall size, font size, and other things? Someone
Okay,
is
the
complaining.
overall. Okay, is it good now?
I
You want this, right?
Yes, yes. This is good
Is
now.
it
Yeah.
good now? I hope. Okay, okay.
Okay.
So, so you can play around like the even the font size of this. Okay, and these are some of the basic arguments that you can pass to all these functions and make your plot as good looking as, let's say. Okay. And sometimes what you also care about is something called as a tick, right? You can uh, play around with the ticks. Okay, you want, let's say, the minor ticks to be on. Then what you will have is all this. It's a good visualization by, if you for like when you are doing some data analysis, it's a good way, like, to have all these things. Okay, so okay, and yeah, and some other thing that you can play within here is, let's say, you can of course play how you want to change the text. Let's say I usually do it the tick params, and let's say then you choose the axis. Okay, let's say both the axis, that's the x-axis and the y-axis, and you want to choose which ticks. It's a major and the minor tick. This is your major tick and this is your minor tick. Okay, and you may add, let's say, what is the length that you want to set. Okay, let's say 5. Okay, and what is the width of the sticks? You may set to, let's say, 2, something like that. Okay, and let's say what is the direction, like currently it's in the out direction. You may call it in the in, you may call it in the out. Okay, in out, something like this. Okay, then you can do for the same thing. Okay, let me copy this thing. Okay, and I'll just do this and let it make 2, and be 0.5, something like this. Okay, so yeah, this is how you can customize your text. Okay, this is okay. Yeah, so yeah. And let's see what other things that you can do. Of course, if you want to save this figure, then you can use this function savefig. Okay, and give a name, something called, let's say, name test dot anyway, png, pdf, whatever you want. Okay, so if you do this, then you'll see. Okay, it's taking time, but yeah. So you see the image gets saved. Okay. So one thing that you need to remember is that savefig has to come before plt.so. Okay. Uh, Otherwise, I don't think your image will be checked. Okay. Check this thing. Okay, I think okay, Python 3 must be having a nice thing. So anyway, you can do in the Python 3, you can call it before and after, it doesn't matter. Okay, good. So these are some of the customization that you can do, and what other thing that you can do is okay. What you can do is I think. Uh, you must be knowing some like you're having, let's say, having smaller images inside a big one. Okay, so what I'm talking about is the inset functions of a matplotlib. So basically what I want is that, let's say, you have a full distribution. Okay, you have a full distribution of sine theta between 0 to 2 pi, but let's say you want to have a particular distribution, let's say pi to 3 pi by 2 or something like that. Then, and you want to keep that smaller inset plot within this big one, then the very simple way to do that. See, first, one thing you have to remember is that it's a code, right? And there's no unique way to get the same thing. Okay, so you may try a different combination of writing how you can achieve the same goal. So yeah, it doesn't have to be my way. It doesn't have to be. It can be everywhere. Okay. So it's just a code. So you can play around with that. So what I usually do is like what I do is, let's say I create some inset axis, okay, and I'll define the let's say the placeholder, okay, where I want that the small guy. So let's say this is bottom, this is something like this. You can look into this thing. And now, so okay, this now what I am trying to do with this thing is I am defining the position of the smaller plot, let's say. Okay. So basically, I'm trying to say where my small plot will be inside this big plot. Okay. So let's say I redefine x1 as, let's say, numpy in space, and I want between, let's say, pi to, let's say, how much do you want? Let's say 3 by 2, something like this. 3 pi by 2, okay. And I want the 100 number between this two guy. And I want y1 to be what sign of, let's say, x1, okay. So this is my new data. So basically, what I'm trying to highlight is that how does so sometimes what happens is that the important data gets buried within that big distribution, and you want to highlight that small peak, let's say. Okay, usually in the particle physics, it's very important to know this sort of plotting. So, and by the way, I'll be using most of reference to the particle physics, so please don't mind that. So then what I would do is I would call this my axis and say, please plot my x1 and y1. Okay. Okay. So let's see what it will do if, yeah. So you see, this is what I was talking about. So this distribution, right, is a complete distribution between the 0 and 2 pi, right? Is a sign distribution between 0 and 2 pi. But if you are interested, let's say somewhere between pi and 3 pi by 2, or some any values that you want, or sometimes let's say you have some specific data where here you see a very small peak, right? If you have seen a Higgs distribution, then there's a very small peak at 125, and if you want to highlight that thing, then this is a good way to do that. Okay, but it's not the only way. Okay, as I am saying, there is a code, right? There's multiple ways that you can have. So, and same customization you can use here. Let's say I want this same label sine theta, and you want color to be, let's say, okay, fine, blue. You want the line style to be, where ls is the short form for line style, lw is the short form for line weight, something like this. Okay. And yeah, this is, I think, let me call this guy a legend guy, and let's see. Fine. So this way you can play around. Okay, you have a data, and you have, let's say, x value, and you can create any function out of this x value, right? Sine theta, cos theta, anything, and you can play around with this one. And if you want to have a, let's say, you might want to have a title for something like this, title. Then let's say this is a test ML for image. I don't know, something like this. Okay. Then this is how you will get the title of your smaller inset plot. Okay, so these are this is quite important, if I may say, because and this customization you can play around, you can try, because once you because like to at least to know how code works, you have to have your hands moving, right? So uh, uh, So I think this is a good way to start Matplotlib. Okay, you can work around with the figure size. You can work around with the line style, line width. You can play around with the color. You can play around with the minor text, major text, right? Labels. Even you can play around with the inset images. Okay, and sometimes let's say, and the second thing, common thing that you can have is like let's say. Mm, yeah, in a same canvas, right? In a same canvas, you may have multiple curves. Okay, you may have multiple curves, and what you need to do, is, like let's say you have a function f1 is sine x, sine of sine of x, and let's say f2 is cos x, and let's say f3 is your sine x and cos x, and you want to show these three functions in the same canvas. Okay, first thing you can do is you can just define your figure size. Okay, figure size, okay, let's say for 3. You can also define your DPI dot per pixel per inch. Okay, let's say 200. I think by default it's 100. And to have this three curves within one one canvas, what you have to do is you just have to call. Let's say we have defined x already, and let's say this is np dot sine x. Similarly, you have to write multiple times. Okay, but you can write a function for you if you want. You can write a function to automate this guy. No problem in that. Okay, this is just some basic way that you can try. Okay. Okay. So let's see how it looks. Okay. See, this is what I'm talking about. Okay. So you have three different. Okay. Okay. So you see, you have three curves in the same canvas. Okay. Now what you want? You want some labels to identify them, right? So what I will do is I'll say this is sine theta. Or rather, I'll just say sine of phi. Okay, let's say whatever. This is sine theta. This is, let's say, cos theta. And this is, let's say, sine theta, cos theta, right? And for the label to appear, what you have to do is you have to call in the legend function, right? So, okay, I missed something here. Okay. Okay. So now the colors are selected by automatically, and you see for each curves you have individual labels. Okay. I mean, you can always play around with this guy, something like this. And let me decrease my DPI. This is taking too much space. Let's say, okay, and I'll say this to be this. Okay. So okay, perfect. So this is one of the way that you can have multiple curves or distribution within a single plot. Okay, and similarly, as I have told you already, you can add other things like labels, and let's say, and even if you want to put a text, let's say, okay, you want to put a text that, let's say, uh, uh, this is the position of the x coordinate, and this is the position of the y coordinate. And let's say you want to put a text saying, okay, this is my first time doing Matplotlib. Okay, let's do this. Okay, and I'll just do this. Okay, so let's see what happens. Okay, this is a way, like, plt.text, and you give a coordinate where you want your text to show up, and this is a way to put in the text that whatever you want to put it. Okay, and this is how you'll do that. Okay, and now, sorry. And what the thing that I want to talk about is, yeah. One thing, yeah, important is what we usually call as the subplots. Okay. Now, what does subplots do? Like, why do you need subplot? Is that suppose what you may want is that you may want a multiple plots within one, let's say, page or something like that. Okay. And then at that time, what we usually use is the subplot functions. Okay. So for that, what you define is, let's say I define some figure, I define the axis, and I use the subplot functions. Okay, plt.subplots, and before that, and whenever in doubt, like, and like you want to know what exactly the function do, then you can do this, and see, you will get everything. Okay, so in Python, like when you are in the notebook or the lab book, you can always do this to figure out what exactly this function does. Okay, this is a good thing to remember, double question mark, and you get everything. How does it work? What to do? Okay. So whenever you forget something, just call this thing, and it will return complete information. Okay. So please do remember this. Maybe you already know this, right? So let's say, and this is the number of rows that I want, and this is the number of columns that I want. Okay, and you can define the figure size. Let's say figure size is, let's say, something I want to bake. Let's say 12 and 5, and you want to say the x boundaries. Okay, and I want to share the x boundaries. Right? Okay. So, and now what you have to do is, now you have defined, you define a page. Okay, you define the page. Let's see what if you can see anything. See, this is what you have defined till now. Okay, so by saying plt.subplots, number of rows is number of rows and number of columns, that is there are two columns, and you are setting the x, that is these guys are having the same what do you call this thing, x lengths. Okay, now all you have to do is you have to put put the curves that you are interested in. So in the first, let's say, panel, in the first panel, okay, you'll how do you define that? I'll say ax0. Okay, so because indexing in the Python, it starts from 0, right? Sorry. So in the first ax0, what do you want to put? Let's say I want to put what do you want? Be something called as cos 2x. Okay, I think. And okay, and what other do you want? You want to put the y label also, set y label. Okay, and what is this? Cos 2 theta. Okay, let's see this. Okay. So the first panel, you have done your work. Okay, you have created two canvas. Okay, and in the left canvas, you have already filled what you want. Okay, and similarly, if you want to fill the second one, what you do is you can use. So now it's a Python game, right? 0, 1. Let's say, please give me the plot of what do you want? Let's say sine 3x. Okay, sine 3x you want, and you want the set y label r This, let's say this is quite easy. Perfect. So this is what you want, right? But sometimes, this is just two guys, two panels. Then it's okay to code all this and that. But what if you have, like, let's say, let's say 4x4, something like this. Okay. 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 Now, why? Because I mean, why I'm trying to highlight this because sometimes you may be interested in having a multiple panel, right, in a single PDF or a single page. Then you have to fill by hand, right? You have to create, you have to do all this X0, 0, something like this, right? Row 0, column 0, something like this, right? Right. So this becomes very, what do you say, cumbersome, right? Then what you can do is you can define a function, right? You can define functions. For that, I think I have created, yeah. So let me call my helper function. Okay, import create subplots. Okay, so basically what I'm trying to tell you is, let me show you this. Okay, so this is a very simple helper function that I've created to show you how you can automate all these things. Okay, of course I will share this all this with you guys so you can have a look. Okay, it's not important like to go into all this. Okay, so I will call my helpers. I will call my function create subplots, and let's say and you want to define and this. Let's say you want to define a function. Let's say sine of x, and f2 is cos of x, and f3 is what do you want? I don't know, tan of x. F4 is cos of 2x, and what I just have to do is, let's say I define functions is, let me make a list of this function that I have created. Okay, F3, F4, and let's say even you want to make a list of the labels. Okay, and I'll just assign it, even you can remove this thing, not important, 10x, and this is cos 2x. Okay, and maybe what do you want? You want different colors? Okay, you want, let's say, colors different. You want red, for blue, what is green, and I think this is black. Whatever it is. Okay, and now if you look, I will share this helper code with you, and you can look into this function, create subplots, and let's say now you define, I want the number of rows to be 2, number of columns to be 2, and what do you want to plot? You want functions to be plotted. Okay, and labels to be what is, how do I define labels? To be labels, and colors to be colors. I think it will do the job. Okay, create subplots, function numpy array is okay. So okay, not an issue on this. Okay, you can, of course, what you can do is you can define actually function of this. Okay, you can actually define this thing, define up to this. Okay, let's say we want to return because that's okay. And format to, okay, let me make a because I have a defined the functions the way I have defined over there may not take your numpy list. Okay, so you can play with that also. That's not a big thing. Okay, let's see. Yeah, perfect. So this is what I want to tell you. Okay, so you don't have to define 4x4 panels and then write in each panel do this, do that. And you can just automate things, right? You can just do that. Perfect. Okay, and next is what do you want? Let's say maybe you want to talk about next important thing that most is the histogram, right? So it's a histogram plot that usually comes in our daily research thing. So for that, let's say let's generate a data. What you want? Let's say I want np dot random and a normal distribution. Okay, and normal distribution with mean. Let's say 0.0 with STD equal, let's say 1.0, 1.5, anything, and how many data you want. Let's say 1000. Okay, and similarly, you can define the fixed size, or you may not. You can always work with the default, but for the presentation or even for your journal article, you may want. Okay, that depends upon you. That depends upon you. So the way to plot a histogram using a matplotlib is to call this HNST function. You want to see this guy, what plt.hist does, you can just do as I told you already. You just call plt.hist and just do two question mark, and then you will get a detail about everything that you want of this particular functions. Okay, so so it takes so what and what it takes is it takes an argument of data. That's your data, and there are. Let's see first what it how it looks. Okay, let's see. Okay, so this is how your histogram plot generated out of a random normal distribution looks like. Okay, so mean is 0 and standard deviation is 1. So again, you can customize your histogram plot. Okay, you can define the number of beans. Okay, you can define the number of beans. Let's say how much do you want? Do you want 30? So I think it's in the from the steps lecture. You know how bin width, bin, all these things comes into play, right? So I define my number of beans to be 30, and let's say what other things do you want? Is the same thing that I have shown you in the plt.plot functions. Okay, you want a label. Okay, fine. You want label to be, let's say this is the I don't know, normal distribution. You want, okay, to be, and you want color. You want the color, let's say color to be red. Okay, and since you are using the label, then you need to bring in this big guy, legend guy, and just perfect, right? So this is your histogram plot, and some customization that you may be interested is you may currently the label is the tick label is the rectangle. You can change it to the line, and for that you can bring in the line 2D and make it 00. It's the easiest stuff that you can do. Okay, you can play around. And one important thing that usually comes is normalize the distribution, and you may heard this thing, normalize the distribution. What exactly it means is that the area under the curve is set to 1, and in matplotlib in the histogram function that you can achieve by this guy, density equal to true. Okay, so now this makes your area under the curve to be 1. Okay, but you can achieve the same thing by using the weights. If you predefine the weights, okay, predefine the weights by dividing the number of rows by the you can create a numpy array where you define where each element you define by dividing by the number of rows. Okay, that's way also you can set a weight and you can call in that weight, and again you achieve the same normalized distribution. Again, I'm telling you this, it's a code. There's no single way to achieve the same thing. There's many way. You can always try different ways. Okay, one other thing is that now currently it's the field histogram. You can just do this his type. Okay, his type to be step. Then you see it's on field histogram. Okay, and same goes with your X level and Y level. Same goes with this legend functions you can play around. Okay, so this is how you can achieve a very simple way of doing away with the histogram plot. Okay, now next is I want to talk about what I want to talk about. I want to talk about, let's say, okay, I talk about customization of plot, insert plot, multiple subplot history. Okay, let's talk about bar plot. Okay. This plot function, histogram function, this become important when, like, you have continuous data, right? But sometimes you may have categorical data also, right? So what I'm trying to say is let's say bar plot. Okay, what exactly I'm trying to say is, let's say you have some quarks. I don't know. This is up quark. This is down quark. What is this? Strange. And you have charm. You have beauty, and you have top. So for the particle physicist, it's easy, but for those, I beg, I apologize. It's just some words that we commonly use in particle physics. Okay, and let's say in an experiment. Okay, even though you cannot no you cannot this tell this is this up and down or is strange and this and that. Let's say somehow you count this the number of up quark. Let's say it is 13. Down quark, let's say it is 25. Strange, it is 10. Charm, it is 8. Beauty, it is 5. Top, it is 3. Okay, so this is what I'm talking about, the categorical data. Okay, you have data, you have, let's say, a type of a quarks, and how many quarks of that particular flavor there are. So then what you can do is I'll just say I'll call my specific function, and I'll do plt dot yes, bar. So again, if you want to know, you just do this. Bar plot is usually taken by plt dot bar. What you put the quarks, hierarchy quarks, and to support the count, you just put the counts. Okay, and let's see what it will give you. Okay, so see, this is what I'm talking about. Okay, so maybe I will just do this to. Okay, no, let it get too hard. Okay, so this is what I'm talking about. Okay, so you have a specific flavor, or you have a specific parameters like up, down, strange, and okay, my up is this much, down is this much, this okay, something like that. Then in that scenario, the bar plot is the best way to represent. Okay, so you again, the customization is the same thing, that same way you can customize it that I have shown you in the PLC dot thing. And there are a couple of things you can. I think this is the WI. Yeah. You can play with the weights and let's see if it let's see if it works. Yeah, yeah. You can change the width of your this bar. Okay, you can play around with it, and yeah. I mean, until and unless you don't give a like make your hand dirty, it's quite difficult to make yours. So please do try all these things. And what do you want next? Let's see. Okay, maybe we can have a pie chart also. Yeah. So pie chart says you. I think all you guys know what is a pie chart. It's a round chart where this has been segregated. Okay. So what I want in pie chart is okay. Data has been defined. 1, 2, 3, 4, 5, 6. Okay, what I want maybe different colors, maybe. Okay, okay, I want colors, and let's say for I, hmm, okay, range length of what was that counts maybe. Yeah. Okay. So I will define my color to be, let's say, the some combination of the RGB. Okay, some combination of the RGB. Let's say random dot uniform. I hope it should work. I don't know if it works. Anyway, let's try this. Let's try this. It's no harm in trying, right? Uh, 0.25, something like this. So this is like I'm setting rate to be 0.5 or something like this. Okay. Let's see. Okay, 0.1. Let's try. Say colors dot append RGB. Random is not defined. Okay, my bad. Import random. Uh, is random chart. RGB equal to random uniform missing one. Wait. Okay, sorry. It should have been comma here, right? Okay, can we just print colors? Okay, so perfect. This is what I want. Okay, this is the combination of RGB that I actually want. Okay, so then what you can do is let's try with the pie chart. That's your pie plt dot pie. Okay, so okay, I'll not check it. I think okay, I think this would be your counts. Okay, and labels would be your uh, what's let's see where did that go. And, okay, let's just see that. Okay, perfect. Okay, I don't have to define the color, so it's I thought I have to define a color, but there's the automated. Okay, so you see this is what a pie chart looks like. Maybe you can put some percentage inside it. Way to do that is, let's say, okay, see. So this is the percentage that you percentage of each flavor. Okay, that's available. This is not very used thing in at least in Cosmo or the what do you call higher in the particle physics. Okay. And okay, just for you to let you know that you can achieve this sort of plotting also. Next is okay, important sort of plotting function. That's your let's say uh, when you have, let's say, a when you want to have sort of a correlation plot, okay, a 2D correlation plot or a 2D plot, and most common use is your his2d's functions, okay. That's for your, let's say, 2D histogram plots, okay, or the heat map sort of thing, okay. So for that, what you need is, I will just call one important functions class rather, okay. So I'll call from a matplotlib colors, I want import log norm. Okay, so why I'm calling log norm is that usually in the 2D histogram, you want your color to be in par with the intensity. Okay, scale. Okay, on a log scale. Okay, so for that, let's say you want to generate some data. Let's generate some data, and okay, this is I'll just give you a size, okay, but let's take everything in the by default, and okay, random dot normal. Something, let's decrease the size, okay, let's decrease the size. Then same thing that I have talked about. You want to define your PLT figure and take everything to be in the, let's say, default version, okay. And this is what I'm talking about, his2d, okay. This is what I'm talking about. And what you want is, you want is a histogram plot of the two functions, two variables, x and y, okay. And let's say you want a bins of, let's say, 50, okay. And let's see what it gives you, okay. Let's see what it gives you, okay. This is what it's looking like, okay. So maybe you want to increase the number. Okay. So this is currently what it looks like. What I'm trying to highlight here is that I want to customize it. Let's say I want to normalize this distribution with the log num functions. Okay. I want to normalize this. Okay, so this is how it looks like. So basically your log num, what it does is, it's usually used to scale this color intensity, okay, on the log scale. So so sometimes what happens is that one of the values is too big and the other values is small, and you have very weird sort of guys, right? So it will take care of that, okay. So one other arguments that you can pass is, you can pass your color map thing, okay. So this is the guy, okay. Maybe let's increase this and let's see how it does, okay. So this is how you can achieve like a plotting of a two variables, okay. You can see how they are related, okay. And one other thing I want to talk about is this guy color bar. So what it does is, let's say it gives you a scale, okay. In the log scale, it gives you a scale. Let's say you are counting some you are playing some counting games, okay. And okay, I have to say, please, this is my label, okay. Okay, so see, so this highlight, so for an example, you can say that, right, there are huge number of events where those are centered around, let's say, at the 0, 0, because it's by default you are taking two normal histogram, right, two normal distribution with the mean 0, 0. So it's sort of maybe you cut a section of it and you look from the top view, okay. And yeah, this is also very important. But please make your hand dirty and just keep on doing this stuff. Okay, and The other thing, let me come back to my this thing what I want. Okay, 2D is done, 2D histogram. Okay. Now I want to talk about the scatter. Scatter is not very different to what I have already shown here. So let's say, okay, I want to scatter plots. Okay, I want to do this, and mm, okay, I have. What if I just say BLT scatter X and Y? Okay, X and Y. Maybe I decrease this guys over here. Okay, okay, I'll decrease this guy and I'll just say PLT data scatter. So this is also sort of a correlation plot that this will highlight you like how the two datas are correlated. Okay, how one data is behaving with respect to the other. This sort of information you can have via this scatter visualization. Okay, and yeah. What do I and one thing I want to okay do is yes what you can do with the scatter plot is first I'll show you this guy. Yes, so what I'm trying to achieve here is I'll talk as you can see over here, right? The marker is of the same size, right? Marker is of the same size, right? You have x data, which is the normal distribution. You have y data, which is a normal distribution, right? And you are trying to find, let's say, how are these two guys scattered in the 2D plane, right? So, but you can use this scattered plot, and what you can do is, let's say, what I'm trying to achieve here is that I'm simulating, let's say, 100 particles. Okay, there are 100 particles. Okay, and I am like I'm defining the transverse momenta of that 100 particles as a random exponential in a random exponential functions. Okay, with lambda equal to 50. Okay, and I'm defining the eta position of the particle to be the random uniform between -3 and 3. Okay, and size to I'm setting it size to the number of particles. Now, one more variables that I am setting is the energy of that each particles. Okay, of that each particles. Why I'm doing this? Because I want the size of that marker, okay, of that marker to be proportional to the energy of these particles, okay. And next you can play around. Let's say out of this 100 particle, there are four classes of particles. Let's say electron, muon, there are jet, there are photons. Okay, and particle type you can easily set as a random dot choice, right? What it will throw is it will throw 0, 1, 2, 3 with the equal probability, right? How many times? Times to the size of the number of particles. Okay, so after doing this, I'm just saying plt.scatter. I'm plotting pt. I'm plotting pt with respect to eta. Okay, size to be now here. This is the marker size, and I'm setting it to the size where size is given by energy by 2. Oh, where why I'm using energy by 2? Okay, if you want, you can just say size to be equal to energy. Okay, just to make my plot, like nice. Okay, otherwise it will just be big blobs will come. So this way you can see, right, here you can easily visualize, right, uh, uh, I mean, huge transverse momenta. If given a huge transverse momenta, you are having a larger energy, right? How you are telling this is the particle are having a large energy? Because we are setting the size of the marker to be in proportional to the energy of that particular particle, right? So here 0, 1, 2, 3. That's the particle type, right? Maybe okay, magma, what I want, jet, something like that. Okay, okay, see this. Okay, You can have, okay, I have given here, okay. You can have a different different color maps over here, and you can just call in by saying from matplotlib import color maps, and you just print out list of color maps, and you'll get a whole lot of this every color map available in the matplotlib. Okay, let's try this. How it looks like. Okay, let's see how does it look like. Okay. Let's see. Okay. Okay. Now you can play around, right? You can play around. So this is one important aspect of the scatter plot that you can use, okay, to represent your data. Okay. Next, I want was to talk is the contour plot. Okay, contour plot. Why it's how come it becomes useful is that you, let's say you have a function made out of two variables. Okay, here let's say I'm defining a function of fxy where it's a function of two variables x and y. Okay, so I'm returning np sine square plus cos square. Okay, so one thing what you need to do is once you define x and y, you need to create a grid. Okay, you need to create a 2D grid. Okay, made out of this x and y. Okay, and for contour plot, you have to call in your contour f function. Okay, so if you do this, let's see, this is your contour plot. Okay, and yeah, I mean, for the beautification customization, I have already talked about. This is just for you to make you feel that what different type of plotting that you can achieve using Matplotlib. Okay, and next I want to show you is your you must have seen this surface 3D plot, right? You have a 3D plot. So what I have to achieve that, what I've done is I've defined eta and phi. Sorry, again, it's a commonly used language in the particle physics, eta position and the phi position. Okay. And I'm creating a grid. Okay, it's a 2D grid out of this eta and phi. And I'm using the energy deposition. So what I'm trying to achieve here is that I'm defining two jets. Okay, let's say if you haven't heard about jets, let's say I'm defining two particles. Okay, I'm defining two particles at defined by this position eta and phi. Okay, and I'm returning the combination of these two jets. Okay, and I'm sorry. And then for to achieve this 3D plot, the function is plot surface. Okay, where the argument is eta grid, phi grid, x, y, and the functions. Okay, that's your energy. For a moment, let's say it's an energy. Okay, and this is what you can get. Okay, this is what I'm trying to talk about. So somehow I think maybe in your notebook or in your code, once you have this, you can rotate this by pointing this mouse, which I'm not being able to do this, but this is what I want to highlight by saying how you can achieve a surface plot in Matplotlib. Okay, this is phi, this is eta, and this x, y, and this is the jet directions. Okay, this is okay. So let me just change this elevation to. Okay, so this is your surface view. Okay, this is the surface view. Okay, maybe this was fine, I think. Okay, let me change the azimuth to 0. Okay, so this is a fun view in it. Like you can change. Like if you don't have, like because I could not rotate this plot with the mouse, which usually has to happen. So I'm just hard coding this. Okay, this is a very let's say poor way. Okay, this is a bad way to do all these things. Okay. So this is what you can achieve using surface plots. Okay, plot surface functions in the Matplotlib. And next, I wanted to show you this how you must have seen how what do you call this thing animations in the plot works. Okay, but somehow this is not working in my notebook. Maybe I will share with you. You can of course play with this. Okay, to see this guy happening. Uh, what I so basically, here's 10 different plots, which I actually didn't want it. So basically, what I want to show you was that the animation of how the probability of heads and tails changes. Okay, as you increase the number of events. So basically, it's I don't know if this guy. Okay. I have already have this. So this is a coin flipping experiment that I wanted to show you how these two guys, how the distribution of the probability actually behaves when you have a large number of experiments. Okay, so when this goes very big, right? Your this red and this suit become equal. Okay, so this is what I'm trying. I wanted to show you, but this is not happening in my thing. So what other thing I wanted to discuss? Surface plot, this and this. After that, it's pandas. So I think this. I am pretty sure most of you have done all this thing that I have said here, and it's just some sort of recap to you guys. So I think maybe I'll stop here, and if there is any question, I'd be happy to answer.
Uh,
Uh,
Amir, would you do pandas today itself?
uh, I have some time, right?
Yeah, you
But
have time. So, do you want to conduct the quiz, first quiz, the matplotlib,
yeah, sure. Okay.
and
Let's do that.
then,
Okay.
yeah,
Uh, okay. Good. So at least there is no question there. That's a good thing. Okay.
so let me share that link. I have it.
Using helper, does the scale of remain the same? Okay. Neeraj, yeah, you can. Sorry, where the question goes? Yeah. Oh, there are a lot of questions. Okay, not a lot of question. Okay, so okay, what is this? Can you please do? Okay, okay, that I did. Can you explain direction and what is major and minor? I think I did this. What is major and minor is let me go here only. So you see, no, let me go here. So I have maybe I'm repeating myself. This is your major tick. So where the number 1.00 is denoting by some big tick, that's your major tick, and this small guys is what is the minor tick. Okay. So can you explain direction exactly? So direction, what I was trying to highlight is that now if you, okay, so this is very bad representation. Maybe I will make it,
Mirza,
hang on a
I
moment,
think
hang on a moment,
I
hang on
think
a
you are
moment.
not sharing the screen.
Oh, okay,
Yeah, you
okay,
stop sharing this thing.
okay, my bad. Okay, I think, but to explain that, I don't require to share. Okay, so anyway, so can you explain direction? That's the direction of the major and minor ticks where you want to put, where you want to direct your ticks. Okay, it can be inward, it can be outward, it can be both inward, outward. Okay, I think major ticks are 0, 1, 2, and minor ticks are the and inward and okay. This is the answer that has given by Saswata. Great. Using helpers, does the scale of remain the same? No, you can change it. Yes, of course, it can be changed. I'll share with you. You can play with that. Okay. But sir, I'm not. You can call me that. Okay. Can you please show the scattered plot again? Okay. Now I have to share this guy. Okay, the screen is visible, right?
Yeah,
Okay, perfect. So where's the scatter plot? Where's this? Okay. So this is the 2D histogram plot that I want. So so a scatter plot you can achieve via this function plt.scatter. Okay, but maybe you want to see this guy. Okay, you want to see this guy. Okay, so here you see the size of the markers is defined by the energy. Okay, so, so there are 100 particles, right? 100 particles have 100 different energy, right? So, and I am setting the size of the marker. You see here, s equal to size, s equal to size, or maybe too much of commands over there, s by 2. See, I am setting the size of the marker to be energy by 2. Okay? What the heck of it? Okay. So this is saying that this is the scatter plot where the size of your marker is proportional to some function, some arguments. Okay, this is helpful. Okay, okay. So, but the basic funda remains the same. Okay, there's nothing here, big here. You just do PLT does scatter, and everything is the same. Okay, okay. I think
Yeah.
that's clear.
I guess we can have the quiz for 5 minutes.
Okay,
Okay.
okay.
So let me say that this quiz actually is we can have for. So what is your estimated thing, Amir?
I mean, like 5 is more than enough, more than needed. Yeah.
5 is more than. Okay. So okay. So then I share the link. Okay, and it is accepting this string. Yes. So now you can start answering this particular quiz. Once the quiz gets over, Amir will start the second part, which is the pandas, and there will be second quiz at the end, which is the pandas quiz. Any other question can be answered after the quiz.
Okay, what is the need of PLT dot listen before PLT dot so? I mean,
Yeah, Amir, we
PLT
can
dot.
discuss this at the end.
Oh,
Right now,
sorry,
we
sorry.
will go through the quiz. Roughly 30 seconds are left. You may want to hurry up. Please. Last one. Yeah, I'll give you 30 more seconds. Hurry up and submit. I give you last. Okay, submitted. Many people have submitted. Good. So I'm closing the quiz now. Okay. So thank you, everybody. We may take few minutes break, and then Amir will continue on the next part, which is the pandas.
Hi, sir. Should we begin, or is there a break or something like that? I think
You can
it's good to.
keep on answering the question. Typically, we give a little bit of break in between.
Okay, okay. What is the okay? There's just one
A
question
couple
to
of
be
minutes, not
answered.
much. So meanwhile, there
I
is
think
a
I think well, sir, my this because the matplotlib list was not very heavy, so I think we can just continue. I
yeah,
mean,
yeah.
just
So typically after the quiz, a couple of minutes just to. So let's just say in 2 minutes you start. It's 54 now,
perfect, perfect.
56 we can start.
Sure, sure. Okay. Okay, I just want to answer this. What is the need of
Yeah,
PLT.listen?
yeah, you can continue
Because
answering.
because as you have seen, we have defined a label for our curves. Okay, and for that label to come in our class, we need to bring this PLT.listen. Okay, without that, the label that you have passed as an argument in your plot function won't be represented in the plot. Okay. Okay. So, sir, so we begin at 3:57, something like that. Okay. Hi, sir. Should we start? Okay, I think we can begin with our next session. Okay. Uh, Let me share the screen. Okay. And here I was doing my thing. So I think the screen is visible. I can't see the chat. Can somebody just speak up here?
Yeah, screen is visible.
Okay, perfect. Yeah. So yeah. Okay. This is okay. 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 So what we will do in this session is what we call as the I will try to introduce the pandas data frame. Okay, it's a very very powerful I would say very common data frame that's being used in the like in many in the current data analysis things. Okay, it's getting too much popular that I think you should also be made a little bit familiar with it. Okay. So, I would like to begin by saying that there are mostly in the foundation of the pandas, there are mostly two basic data structure. Okay, what they are is one is the series. Okay, one is the series. That's one guy, and the two is your data frame. Okay, in the pandas, there are two data structure. One is the series, and one is the data frame. Okay, so let us import something. Okay, let me import numpy. Okay, numpy has already been imported, and I want to import pandas alias as pd. Okay, so pandas has been imported. What you okay? If you want to install pandas, and I would suggest you do this pip install pandas. I think that will help. If it's a pip or pip3 or pip2 or if you are in the condas, then it's just conda install pandas. Okay. So let's let's try to understand what series is, what a data frame is. Okay, let's say you have a list. Let's say 1, 2, 3, 4. Okay, this is your list, and you want to make a let's you want to convert this into a panda series. Okay, what how you can do this? You can just to achieve this by saying panda dot series, and you want to see, and if you just print it, no, this is what is this data. Okay, sorry. So this is the series. This is the panda series that I will. That's being. You had a list A, and it's been converted into a panda series. Okay. So you see this 0, 1, 2, 3 is your index. Okay, is the index, and 1, 2, 3, 4 is the values. Okay. So sorry, you can actually if define your own index. Suppose let's say maybe C D, and let's see, right? So this way you can also define your own index, or you can work with the automated default index. Okay. Next is now, since this is a series, what a data frame is this? A data frame is usually have you I'm sure you have seen this Excel sheet, right? There's a column, there's a row, is a tabulated data structure, right? So Panda data frame is exactly like that, but much more than that. Okay, you have a different, you have a huge functionalities that are buried within that data structures. Okay, so let's say you want to create a data frame, okay? Pandas data frame. How can you achieve that? You can achieve that by calling pd.dataframe class. And let's say I will make a dictionary, okay? And I'll say this is my column name, and this is my values, okay? And let's say this is guy, and okay, let's print this. Let's see this. Okay, some oh, okay. Sorry, there has to be a guy. Okay, so a series is a 1D and the data frame, okay? Data frame is basically a 2D tabulated data where A is the column name, B is the column name, and in A column you have a values 1, 2, 3, 4, and in the B column you have values 5, 6, 7, 8, where this 0, 1, 2, 3 is the index of your data, okay? Now again, you can work with the index. Okay, uh, uh, you can create your own index, something like this. Okay, why I'm focusing on index is this. I would like to highlight why index is important. Is let's say I create a data frame. Let's say okay, sorry, just look away. I want this guy, and let's say this is A, and this is 1, 2, 3, okay, and sorry for that, and let's say df2. You define a df2, the second data frame, and you, I'm creating a data frame out of a dictionary, okay, and let's say same column, but 4, 5, 6. Perfect. Now, let's say df1 plus df2. Okay, so df1 plus df2 would give you a single data frame with a single column. Okay, so what they are doing is they are adding up. Okay, element wise, 1 plus 4, 5, 2 plus 5, 6, 3 plus 6, 9. Okay, now currently each data frame is having an index 0, 1, 2. Right now, what I want is, let's say here, I will change the index to 210, something like this. See? So the point I'm trying to make here is that if you had changed the index, okay, this sort of binary operation changes. Got my point? So that's why index is important. Okay, you have to take care of that. Okay, you have to check if everything is fine with that. Okay, so this is a simple way to create a data frame. This is a simple way to visualize. Okay, one more thing I want to show you is let's say what's the type of df1 and a. See, so type of this column is a series. So what you have to understand is that a data frame, a Panda data frame, is made up of a combination of a series, a concatenated series. Okay, multiple series. You concat them, and you will get a pandas data frame. Okay. So this is series. This is the definition of a series and a data frame, and how one can create a data frame. Okay, usually why I'm choosing a dictionary, because it's easy to handle, because I want columns, right? I want columns to be named. I want values to be inserted. Okay, but it's not always like you have to have a dictionary and this and that. You can all you can have you can have through a, let's say, a numpy array. Okay, you can have you can create a panda data frame from a numpy array. Let's say this is 1 2 3, and this is 4 5 6. This is 7 8 9. Okay, so this is your numpy array. So 3 cross 3. Sorry, here's a mistake. 7 8 9. So this is a numpy array. How do you convert it? It's pretty easy. So I'll say pd dot data frame. Okay, and I'll just say df3. Okay, and I want df4 to be printed. So you see, so you have an NumPy array, it's a 3 cross 3 array, right? And you are converting that array into a Panda data frame, right? So if you do not pass in the column names, they would automatically set 0, 1, 2 as the column name, okay? And not a problem for us. What you can do is you can give a column names to this data by introducing argument columns. Okay, and let's say this is A, this is B, and this is C. Let's see. Perfect, right? So this is a way to create data frame, pandas data frame out of series, out of numpy array. Okay, and yeah. So, and how to handle with the columns and this and that. And next thing is that maybe I'll not try to create a data frame, but what I'll try to do is I'll try to load with the existing data frame. Okay, I'll try to load. I have created some file. Okay, so there's a different way to load different sorts of data. Okay, you can I think. Yeah, so you see, one can have different varieties of different data structures, right? You can have clipboard, you can have CSV, Excel, Feather, a hell lot of it, right? But one of the most commonly used format is the CSV format, right? I'm pretty sure CSV has been introduced in your Python lectures. Is a comma separated values. Okay, the way to call it is CSV, and give a name of it. Okay, I have already created, let's say PPHAA. Okay, again, I'm sorry, it's a data related to the particle physics, so please handle. So this way, this is the way that you will load your you load your data frame, CSV data frame. Okay, and you can play around with different arguments. Okay, let's say first, let's say we want to just see we just want to load 100 rows or some 10 rows. Okay, and then just let's say PLT. I just want to visualize what this data is. Okay, so you see this data frame contains 8 columns, but it doesn't have a column name. Okay, it doesn't have a column name. So n rows are, if you pass in the n rows argument equal to, let's say, 10, it will just load 10 rows from your data. Okay, first 10 rows. Okay, it doesn't shuffle and pick out the 10. It just do that. Okay, some other things that you can play around is since there's no columns. Okay, what you can do is you can specify that I don't have a column name. Okay, I don't have a column name. So you see now the pandas understand that you don't have your data doesn't have a column, and they would just, okay, why don't you use my columns? Okay, so their column is 0 1 2 3 4 5. Okay, so But I want to tell you what these column names are. Okay, so this the name of the column are px1. That's the x momenta. Okay, of a photon, and this is basically the four momenta of two photons from the Higgs decay. Okay, so so that's not an important. Okay, that's not an important, but just to tell you what exactly this data is. Okay, it's a data where a Higgs boson is produced by in the collision of proton proton, and that Higgs is decaying to two photons. Okay, so I have defined a list, okay, of column names. I want to pass it, okay. I want to pass it by with an argument, say names equal to columns. Okay, let's see. Perfect. See? So with this argument, names equal to anything. Currently it's calls names equal to calls. Then what it does is it tells the pandas that please use my customized naming thing. Okay. Then the pandas would say, okay, fine. I will use it then. So again, if you are if you don't need, like sometimes in the ML business or this and that, you have a huge number of columns, right? A huge number of columns, but what you do, you only need, let's say, first three, right? First three, something like that. Then you can use this use calls. Okay, use call argument and say, okay, I don't need the whole guys, I don't need the whole columns, I just need pxy and px2, something like that. Then let's see. Okay, then the pandas would say, okay, you want to forget everything, fine, not an issue. Then pass in the use goals argument and define, okay, what are the columns that you want to use. Okay, so in this way things are done. Okay, in this way things are loaded. Okay, so and one other thing is you can highlight is what is my delimiter. Okay, what is my delimiter? By default, it's I hope it's it's comma separated comma, but you can also say if it's tab separated, it's tab separated delimiter. Okay, and there also can be a space separated, right, data. I think Subir sir was mentioning maybe in one of his lecture how to handle that. Okay, here if you have a space separated data, then what you do is I'll just say what you can just do is you can bring in this guy argument, okay, delim underscore white space, and you just say true. Okay, so this is this argument works when you have, let's say, a space separated file, CSV file, whatever file you have. So once you pass in, the pandas would say, okay, now it's a space separated. Then it would try to give you the data accordingly. Okay. And one other thing, important thing is that sometimes your data is very, very big, right? Most people who have worked with, who have done ML thing must know that loading data is the huge headache, right? I mean, because why? Because your laptop has a limited RAM, right? You load the data, all the data goes into your RAM and your computer froze. So this is common issues, right? In a data analysis business. So what I usually do is that because there are a lot of different techniques. Okay, so what pandas provide us is what we usually call as the chunks. Okay, so how the chunks work is that, let's say I read, let's say I read a CSV file, let's say pphaa.csv, and the argument that we have to provide is just chunk size. Okay, so what it does is it will divide your data let's say currently I'm doing is a 1,000 chunk size of 1,000. Okay, so it divides your data in a chunk of 1,000. Okay, so what I'm trying to tell you is that let's say for I sorry chunk in enumerate chunks and so I want to print something. I want to print. Okay, uh, mm, so let's say okay. Okay, what do I want to print? I want this is the chunk. All right, this is the index. Okay, and okay, I want this, and I want chunk dot head. Okay, before using head, I would introduce here what is head and tail. Okay, if you pass in a function, let's say head functions. Okay, what it will return is the first 5 rows of your data frame. Okay, first 5 rows of your data frame. Okay, and you can say, okay, not just 5, I want 10. It will say 10. Okay, and similarly, if you want the bottom 5, okay, if you want the bottom 5, okay, then what you pass is tail, df.tail. You pass in this function, and it will return you the last 5 rows of your data frame. Okay, so let's try to do, yeah, exactly. This is what I'm trying to, this is what I'm trying to achieve here. So you see, uh, uh, I have defined a data frame. I'm loading a data frame such as chunks, right? In a chunk size of 1,000. Okay, and I'm just for this is just for how you load the data in a chunk and you play around. Okay, so basically what happens, what I'm trying to say is that if your RAM is too small, if your data is too large, then you can work with this argument chunk size, and you load the data in chunk, and you do your run your code, write your normal code. Okay, here, and whatever answer you want to here, if it's a chunk wise answer you want to find, then you can do that, or you can store your answer here. Okay, a chunk wise answer here, and of course once everything is complete, you have answer from list of chunks, right? So this is one way. Okay, the chunk is one way to of course to deal with when your data is too much. Okay, uh, next. Okay, now let us load yeah, read our CSV. Okay. One thing that I want to also tell you is that how can you, once you have a, let's say, once you have a data frame, how can you save that data frame? Okay, then you can save that data frame by calling into to_csv. Okay, then to_csv, and then let's say this is like a test haha.csv. Okay, test now let us wait, is the test haha. Okay, it takes time. So anyway, yeah, here's your data frame. Now see, one thing I want to tell you is that ABC, this was your original data frame, right? With the column A, B, C, and this is the entry of each columns, right? And this was your index. But now once you do to_csv, then what happens is that even your index is getting saved as a column. Okay, to prevent it, what you can do is where was that? Yeah, what you can do is you can do index equal to false, something like that. Okay, that's an easy thing. Okay, you can play around. You can have a feel. Okay, and once you do this, things will be okay. Okay, things will be okay. So okay, So this is how you save this save the data frame. This is you can save in currently I'm saving as a 2 CSV. You can save as a dictionary. You can save as JSON. You can save in any format that is available in the market. Okay. Okay. So next, let's move on to more statistics, okay, that we want, ppha.csv. Uh, I don't have a header, and what I don't have I calls is here, and I want everything, right? I want everything, and let's say let's print something. Okay, so this is the complete data. Okay, now what the pandas has is it has an inbuilt is a very good inbuilt functions. Why isn't it coming? Okay, yeah, somehow. Yeah. Okay, somehow, okay, this is not, the new cell is not getting generated. Okay, so anyway, we can always use the same cell. Okay, so I'll stop it. Okay, so what I'm trying to say is that Pandas has a built-in summary statistics, something like that. Okay, so what I'm trying to highlight, let's look in the data. Okay, then it becomes clear. Suppose one of the functions that pandas provide is the describe functions. Okay, so what it does is that it gives you, okay, so it counts the number of rows that you have. I have 4830 for each, guys, for each column. Okay, for px1 I have like 4830. What's the mean of px1? Okay, it's minus 0.29. What's the standard deviation? It's 61. What's the minimum value? It's minus 3 -3 to 4, and these three percentiles or the quartiles, okay, that we call the 25% of the data is minimum is less than -46, 50% of the data is less than -0.11, something like that. 75% is less than 45, and the maximum value is this guy. And why I'm not able to get new cell? Okay, okay. Okay, not an issue on that. We can, of course, have like, let's say you want to see the individual column statistics of a column. Okay, let's say px1. Okay, so this way you will get the details of each columns. Okay, and you can have similarly, you can have an info function. You can there's an info function that you can use, and what it will does is it will count you like a non-null count. Okay, so there are 4830 nice element of type float 64. This is another nice functions that you can use. Okay, and you can also do something like this. I want to see if there is any how many unique guides are there in the px1. Okay, so everything, every values is sort of unique over here. Okay, and there's also called as a value counts that you can use, right? Okay, so this is so uh, I will just stop this. And I will just so you see, I mean, this is how value count does help you. Okay, and yeah, I'm just confused here. My cell is not getting hanged. Okay, maybe what I'll do is I'll open a new Python, right? Let's see. Maybe that right CSP calculator CSP. I don't have a header, uh, and I want to use this guys. Okay, six. Sorry. Both pandas as heading. Oh, sorry, my bad. Let me copy this thing. Okay, perfect. Now, as you can, so as you have seen till now, what is series, what is pandas data frame, how you can create series, how you can create pandas data frame, what is the importance of index, how you can save the data frame, how can you can load the data frame. Okay, so also if you are just interested on loading a particular set of columns, then you need to use calls, right? And there are certain summary statistics provided by the pandas, like describe, value count. There are many. So that will provide you the mean, standard deviation. So in a way, you see, pandas is such a powerful tool, at least in the data analysis, right? I mean, it's there are so many pre-built functions that is available in the pandas that it's so famous currently in the ML sector. Okay, so next is what we usually call as the it deals with the selection of particular rows, selection of particular columns. Okay, so I'll just say here how do you select particular rows and columns. Okay, so to select columns, if you have a column name and if the columns are not very large and you can remember the names, then it's very easy, right? So I would say px1 is like df. You'll pass your argument like this, and this is your px1, right? This is your px1. Okay, uh, but what usually happens is that we don't maybe we don't work with the directly with the column names, and what we usually work with is we use iloc and locloc. Okay, these two functions that we will use in the pandas. So I mean, suppose let's say you want to select a particular columns, right? You want to select let's say px1. Okay, what you do is if you want to use ilog, then what you do is you do 0. So why I'm setting it to 0? Because in my data frame px1 is the first column, right? So first column in Python means the index is 0, right? So and one thing to I want to highlight is that there's nothing. I haven't added anything beside this colon, right? So it means I have to take every rows. Okay, take every rows of the first column. Okay, so this means the way it's like written, okay, colon comma 0, it means if there is nothing here, it means take all the rows and of the first column. Okay, so it takes all the rows of the first column. Okay, so similarly, you may ask like, okay, fine. How about selecting the first column? Okay, or any column, right? So I would say, okay, if you're interested on ilog, then I would say def ilog. This is your first row, right? First row. Each there are 8 columns. Each column has 1 element, right? This is how you do. I mean, also like you can what you can do is okay, now this is how you select all the rows, and this is how you select the columns. But what if I want to have a particular element of a particular rows and a particular columns, right? Then it's also not very hard. Okay, you can pass in the ilog function, and let's say first row, first column as the first element, right? So this is your guide. Okay, and let's say you want a rows a range of rows. Okay, then you can pass in something like this. Okay, so I want this and this. So here is no comma. Okay, just working with the rows. Okay, so 0 to 10 I want. Okay, so it starts from 0, ends in so it starts with 0 and ends in 9. Okay, so this is a way like you can work with the first 10 rows. Okay, it will select all the columns. Okay, all the columns and range of range of rows. Okay, range of rows. Okay. Okay, this is how you can get it. Okay, and let's say all the rows but particular color, all the rows but in certain range. Okay, then all the rows, nothing over here, comma, right? And let's say 0 to 3, something like that. Okay, so this is the guy. So 0, 1, 2. Right. Sorry, it selects the zeroth, and it's not a range. It's selecting a particular columns. It is selecting zeroth and the third. So zeroth is a px1, and third index is your e1. Okay. So this is how you can get. But similarly, if you want a range, I hope you can get this exactly. So in this way, what you are trying to do is you are trying to select all the rows, but let's say I don't want the whole data frame. I want from first column to the third column. Then this is your guide. Okay, this is your guide to give you that particular data section of a data frame. Okay, and yeah, so range so again now you know, like it's now it's the same, right? Okay, I want first three columns, I want first three rows, something like that. So this is how you do that. Okay, so remember, comma is separate rows, and this is rows, these are columns, and I think till now it's pretty clear to you that how to do all this slicing basically. Okay, in Python you call you slice the data of like a particular range and particular thing, right? Uh, uh, so if you want the particular rows and particular column, perfect, right? So it's selecting the zeroth and the third row. It's selecting the zeroth column and the third column, right? Perfect. So, and what other thing that I want to discuss is I want to discuss. Okay. Suppose let's say you have df.head. Let's see what it. Okay, so this is your data, right? This is your data frame, right? And let's say you want to add a column to that. Okay, well, what you can do is it's a very easy way. Is this guy? Let's say I want to create a new column, name label. Okay, with values, all the values to be 0. Okay, and let's see what it got. Okay, so you see it added a new guy, right? It added a new guy, let's say a label. Okay, so I mean so you can also add your own values, like for an example you have like px1, py1, pz1, e1, right? You can what you can create, using px1 and py1, you can create transverse momenta, where you can create invariant mass out of it, right? So, and also maybe what you want to achieve is that something like I want to put a new label, new column, but in a particular place, not in the last one, right? This would automatically place your new column in the last as a last column, right? So uh, let's say you want to add a new column. Let's say then let's say here after pz1, something like that, okay, in the fourth or third place. And what you do is you can use insert function, okay, or you can use the insert function 0, 1, 2, 3 at the top, let's say at the third column, and okay, before that I have to define what do you want to put, right? What do you want to put? Let's say I want to put a pt. I want to put a pt. Okay, okay. I would say pt. What is a pt is np square root. Okay, df, right? It's a df px1 square plus df by1 square, right? So I want to put this, and let's say the name is pt1, the value is pt1, okay? Maybe 0, 1, 2, maybe at fourth position, something like that. And let's do, what is this? NP is not defined. Okay, fourth numpy is numpy. Okay, now you see this insert functions helps you to put a new column, that's your pt1, the transverse momentum of the first photon, in the fourth place, 0, 1, 2, 3, 4, right? So this is how you can do stuff, right? You can add columns, you can, where do you want to add, what you want to add, right? So this is one way to do things, okay? So I think, yeah, DF has been changed, not an issue. And what other thing that you can do is, yeah. So, okay. Before that, you can also drop columns, right? You can drop columns, right, by using df dot drop. Okay, you can use in df drop. You want to, let's say I want to drop this. Okay, and you have, if you provide x is equal to 1, it will drop the columns. Okay, and let's say, so what is this? Df dot df dot x is equal to, okay. Okay. Okay, let me look into this. It should have works. Okay, maybe. Yeah. So df.drop does not automatically convert your data frame. You have to store it. Okay. So, but the thing I wanted to show is, if you want to drop a column, then just use df.drop the drop functions. Okay. And let's do some binary things, okay? Binary operations like addition thing, this and that thing. And for that, let's say, let's bring in df1. Okay, let's call new data frame. Let's read in the new data frame. Okay, and that's your let's say pp.csv, and header equal to none, names equal to calls. Okay, div1, but please bring this guy. Yeah, okay, and df, what was in df1 dot head? Okay, oh, sorry, so this is not, but here I want to check what was the df1. Okay, I want to drop label. I want to drop PT1. Okay, I want to drop this two thing, and I want to see this guy DF1. And
Uh, there is a
yeah,
question.
yeah, yes, please go on, sir.
Aparajita asked the question.
Yes, sir. So earlier you mentioned about that thing, like we can take the zeroth column and third column. Let's say out of
Mm-hmm.
this data frame, I want to make a new data frame using only zeroth and third column. So how can
Perfect.
we also, yeah, uh, Can you
Yeah,
please show us how can we do that? Like make a new data frame out of this data frame only using some columns.
Okay. Let's say let me use df2. Okay, and I'm using all the rows. You want it first and the third, let's say, okay?
Yeah.
Well, anyway, first and the second or something like that, okay?
Okay. I got it, sir.
Got it?
Yeah.
Got it?
Thank you, sir. Yes, yes.
Perfect. Okay. Okay. So yeah, so now I have a df1, I have two data frame, df1 and df2. Let's play with this, guys. Okay, let's do something. Let's say df3 is df1 plus df2. Okay, then what is this? This is addition, right? This is easy. This is, I don't know why I'm saying this thing. So, but one thing is the element-wise addition. Okay, so why I'm focusing its element wise, because you see each data frame has equal number of columns, right? Same columns. Okay, so this is very important. To have a binary operation, the two data frame has to have a same the columns. The name of the column should be the same, otherwise it doesn't work. Okay. Uh, actually you can at once this is done, I would say to you the data, you can create your own data and you can play around, you can change, maybe you will get nan or something like that. Okay, you can, what you can also do is you can subtract it, right? Yeah, you can of course subtract it. What are the things that you can do? You can let's say multiply, right? It's a element wise. What are the thing? You can divide it, right? And yeah, so these are the some of the what is it, binary operations that you can achieve, right? Yeah, so what's other thing that I want to do? Yeah, one important is, I think that I'm missing is how do you concat two data frames, right? You have df1, you have df2, and let's say you want to concat them. Let's say sorry, I want the df1 is, let's say, pd dot concat df1 and df2. Now this is important. If you say x is equal to 0, what it does is it concat two data frame row wise. Okay, row wise. So basically, let me if I can do this df1 let's save. Okay. Okay. So a df1.shape would give you number of rows and number of columns. Okay. What I'm trying to tell you is this very simple thing. dfa dot shape. Now you see df1 has a number of rows 4830, df2 has number of rows 3939, and if you do x is equal to 0, what it does is it concat the two data frame row wise. Okay, so now you have 8769 rows and 8 columns, but what you can also do is column wise, let's say, let's see. Okay, let's say x is equal to 1. So now what is happening is this DFV is the data frame that has been constructed out of by concatenating two data from DF1 and DF2 column wise. But you see DF1 and DF1 and DF2 has different length of rows. So if you print, let's say something dfv dot tail, let's say the for last 10 rows, you see nan thing, right? So why this nan is happening is because you are trying to concat two data frame of unequal number of rows. Okay, so So they don't know, like this guys doesn't know what to do because they are looking for their partner, but they don't find. So it's just that, oh, it's not a number. Okay, it's not a number. So this is also this not a number thing is also very what do you say mm, common thing that you will see. So usually the lecture ends at what time, sir? The evening lecture. I just want to like feel like how much time does it have?
So usually
Uh,
it ends at 5.
it ends at 5. Okay, okay. So then let me just hurry up. Okay. So so this NAN is a headache. Okay, for a data analyst, this NAN is a headache because while plotting, while doing this and that, it causes a lot of problem. So what you can do is, if you once you load your data, you can quickly check DFV. Is there any NaN value in my data? Okay, any NaN value like in any columns. Okay, it will say, oh yeah, of course there's a NaN. Okay, now okay, once you know that there is an n value, then you want to say, okay, there is an n, I know that. Give me the statistics of it. Okay, so it will tell you, okay, there are 16 columns. The first set doesn't have, but the last set has 891 guys as your has a NaN value. Then one easy fix is that, okay, what I want to do is I want to convert all this NaN value to 0. Okay, so now you see every NaN value is converted to 0, but it doesn't mean that every time you have to use fill NA equal to 0. You can use other, like let's say mean of this guy or median of this guy or whatever you feel comfortable with it. Okay, please try that. I'm using na fill na equal to 0. Please try with you fill NaN with the mean of this column. Okay, mean of px1. That's I think more good thing. Okay, and quickly I want to talk about manipulation of the data frame. Okay, manipulation of the data frame. So what I want is, I just want to quickly look into diff1 dot head. Okay, fine. This is fine. Diff1 dot tail. This is fine. Okay, okay. Let me just quickly say, okay, I want to find the mean of px1. Okay, and what I'll do is I'll do this dot mean is your function that will return the mean. Okay, and what I want is I want to create a new, let's say, data frame. Let's say I want to create a new data frame, but before that, let me. Okay, fine. Because I won't be doing that. Let me create this one. Then I would say df1 dot px1 but I'm trying to use the map functions. Okay, I'm trying to use the map functions. Oh, this is to highlight how you can change the values of particular columns. Okay, how you can do this. Okay, and what I'll use is I'll use lambda functions. Okay, I'll try to use the lambda function where every element is replaced by px1 mean. Okay, so this is one way to manipulate your data. You do this. Okay, so things have been changed. Okay, 40 the values of your let's say the first guy is changed because high is your px1. Okay, so similarly currently you are using map. You can also kindly look into the apply functions. Okay, it also does the same thing. And what other thing that I want to do is, okay, let me kindly have uh, uh, this guy till yeah, I want to use this J10. Okay, So what I want is df equal to pd dot concat. I want to concat this df1 and df2 row wise. Okay, okay. But before that, kindly have kindly give me a moment. I'm setting something here. I'm setting a new column, and this guy equal to 1. Okay. I've created df1. I want to show something related to the ML stuff over here, and this df dot okay, just print df. Okay, so I have concatenated two data row-wise, and okay, this is the thing. But what I wanted to show is there is one functionality of the pandas that will that's your correlation functions. Okay, it gives you correlation functions. Okay, and if you look into this core, you see this is how the two how each variables is correlated to the to itself and the other. Itself is always 100% correlation, but with others you can check it. Okay. So one way to what I wanted to actually highlight is this guy. Let me quickly bring this. I think I already have a map. Oh, no, I don't have a matplotlib. Okay. If I upload SPLC, what? I don't have. Okay, okay. What I want to show you is heat map. Okay, heat map of core, and no annotation. Annotation, please annotate my CMAP. I want what the good way? Good one? I don't know. Maybe it's and yeah, format. Maybe I want 2 decimal float. Maybe it is fine. And line width, maybe you can find something like that. And PhD gets right. Okay. So you see, I mean, so if you have given a little bit of focus, then it's sort of what you are looking is binary classification, right? So there are two sorts of objects, and you are trying to classify them, right? So of course you will learn all this thing in the later lecture, but I'm just trying to highlight how by just a data visualization you can come up with a very smart way, okay, smart way of selecting smart features of doing machine learning things. Okay, okay. So this is some stuff that I wanted to show. Yeah, much. I think time is also, yeah, 4:56. I think, yeah. So as a homework, what I want to please maybe I'll share all these things. You can try with adding different columns to that, plotting each guys. One thing, okay. Let me show you df dot hist. If I do this, see. I mean, pandas is cool, right? I mean, but you just do df.hist and you get the plot of each columns, right? But of course, you need to customize using matplotlib and this and that. But it's a fine thing, right? So uh, uh, what you have I have talked about is how you can build a panda data frame out of series, out of array, out of anything, right? And how can you save the data frame? How can you load the data frame? How can you manipulate the data? What is indexing? What is selecting? How can you do all this stuff using iloc, lock, right? And of course, there are so many functionalities within pandas that one cannot cover in one thing. But I want you to look into all those things and please play with the pandas. So I think, Ritesh sir, I would stop here.
Yeah, okay. So there is some
I think.
question you might want to.
Okay, okay. Uh, oh, sorry, not this one. Hi, the please show the chunk function. Okay, okay. Chunk. Where was that chunk? Okay, so okay, this is how this is not the only way. Okay, that's what my whole point of this coding is. This is one way. Okay, so you may learn in a different way. So basic funda is that you define the argument, you pass in the argument chunk size, okay, and then you say okay 1,000 at a time, and then you just do for IA chunk, and you work with your code and you work with that particular chunk, and once that is done, next chunk would be loaded. So it just to be RAM friendly, nothing else. Okay. Could you please explain? Okay, I think this has been explained already. Does it work with the string also? Like I have a data file that can both numeric data and some string words. So of course, not an issue with that. Yeah, you can have a numeric. You can have a yeah, you can have what do you call numeric and character, right? Yeah, that's a string. That's fine. Okay. Okay, my something hit with data is okay. Okay, so I will stop sharing.
Yep.
Yeah.
Yeah. Okay. So now we will have the next quiz. Let me just get ready for that. Okay. And I'll share the link. So this is data handling part 2. Pandas. And so the quiz will start now. It will again be for 5 minutes. Here is the link. You can get started. And those who have finished, you can already start leaving. I think tomorrow at the questions can be answered after the quiz. Quiz has started. So tomorrow at 10 there will be another session on root. Okay. Um, this we have to organize. I have kept the Saturdays as a buffer, so we have to use this time. Continue.
So the quiz is not opening, I guess.
It is not opening.
Opening link is on that I have link is not working.
Okay, just a minute. Now try now. I will just pause there. No, it's not an old link. It's the same link. And
So the Gmail has not been intended.
it reads your ID, whatever you have given. Okay. So whatever ID you are using at the moment, it records that. I send things to your registered ID, but whatever ID you are using, that's what recorded. That's why I asked that use any one ID. Okay, so you have 30 more seconds to go. Amir, do you want to look at the chat box?
In the question, correct syntax to read on the first 20. Okay. Okay, fine. Then if it's the thing, then please, yeah. Leave it blank. Yeah. Not a big thing. Oh, Chandrima Sen as a GF dot hit 20 option is not there. Smart. So maybe there was supposed to have none of the above, maybe. So not a issue, not a big thing. Yeah. It's okay, but I took something
Anyway,
else
so
from
consider
it.
this quiz only as a practice because there have been some issues. Okay, so this will not be graded. Try your best. We'll discuss the answers to this. Okay, this there is some typos and some other issues as well. As one of you pointed out, this particular quiz does not collect the email ID. I just checked it, confirmed. You cannot use these emails.
So yeah, maybe there are multiple issues on that. So okay.
Just as a practice, you can consider it.
Yeah. Yeah, we can have yeah, next quiz, yeah, tomorrow, yeah. In the beginning. Yeah, what suits me. How is data frame different from other data types? So okay, so the answer to this will be
I think so. Let me just say that
I
the
mean
quiz is closed, so I'm
yeah,
just going to close it.
yeah, yeah. So this question would be answered by Tausik tomorrow. So you will feel it how different that is, you know. So wait for tomorrow, and you will see how things are different. Okay.
So tomorrow, I would say that tomorrow data frame thing is slightly different kind of data frame, and you will
Yeah.
understand. So Toshik, you want to say something?
Yeah, so I just want to say that the instruction has been sent out to all of you that how to install and all these things. So there are like 4 or 5 options that has been given. You choose any one of the options that you like to like do, whichever is preferable to you, and install root. And final thing that you have to do in on the last page, it says the now test. You just have to pass all these tests. If it works, then we can start from there. And I would like prefer, although root R data frame is introduced in 6.14 version, but uh, they don't have much many functionalities, so I would request you to install at least 6.26 version. And so that is the thing.
So this is the file that is sent to you, and read it and follow any instruction, any
So
one way of install.
yes, there are like 5 options by which you can install. So
Option
depending
one,
on your
option two,
OS or architecture, you have to choose
option
one
three,
of
option four, and option
option 5.
five.
And then okay. For root uproot installation, there are 2 options, either pip or conda. these two.
And
If you can,
for PyRoot, Tosk,
no, so this is PyRoot. I mean, if you have root, that is. So earlier it used to be called as PyRoot. Nowadays it's like root one.
okay.
When import RWT, it's capital.
How much memory will it take is a question.
Memory for what? Installation.
Installation.
This installation.
Installation might take several GBs, I think, of the order of 4 or 5.
Yeah, I think this root is heavy.
Yes. Let me check for my thing. But you can actually install in your home directory. If your, let's say, root directory is, does not have space, then you can.
Yeah, I have root already. Then fine. Then you just, I think what you need is uproot. Yeah, as mentioned. Can you mention what will be the preferred device and specification? That device is what you have.
Yeah, that you cannot change. Right?
Will we be having new queues in pandas? The current one won't be graded. What do you say, sir?
No. There will not be any new quiz on pandas.
Yeah.
Okay. So idea of quiz is twofold. One is grading, other is forcing you to think.
Yeah.
So the current quiz
Yeah.
has forced you to think anyways. So that part is
Yeah.
done. And we are taking enough number of quizzes that second part, the grading part, will be
Yeah,
there's enough
exactly.
data we have.
So already I have root. Do I need uproot? Yes, of course. You need to install uproot.
Yeah, you need to install uproot separately.
How much memory will it take?
So
Okay.
memory is, yeah, just I checked. So it is 700 MB roughly for my case. So I think within 1 GB it will.
1 GB. Let's say. Yeah. You may be right.
Okay then.
Okay.
I think here I stopped recording.